Hi, this is Mrs. Krivicic, and I am just going to go over what phase changes are. So these are notes, and if you want to follow along, there is a PDF file of these exact notes, and you're more than welcome to take them into Cami and actually make notes on the side, or if you have a piece of scratch paper, you're more than welcome to have a piece of paper by your side and take some notes. So what you want to recall so far is that there are three states of matter. There is the solid phase, the liquid phase, and the gas phase. And so what is a phase change? And I'm going to make my face smaller so that you can see this little comic. This comic says, I was water before it was cool, and it's a little ice cube. In any case, a phase change is when a substance changes from one state of matter to another. So it could be when a substance goes from a solid phase to a liquid phase, when a substance goes from a solid phase to a gas phase. Again, it's any change from one state of a matter to another. And phase changes are physical changes because it only affects the appearance and not the identity of the substance. So if I have an ice cube here on my dining room table and I let it sit overnight, the ice will no longer be ice in the morning. It will be water, but it is still H2O. It's still water. It has not changed. I have not broken apart any bonds. I haven't caused it to change its appearance. It is still H2O, and the identity of the substance has not changed. So what happens during a phase change? During a phase change, heat energy is going to either be absorbed, taken in, or released, pushed out. So heat energy is released as molecules slow down and move closer together, and heat energy is absorbed as molecules speed up and move farther apart. So in terms of heat energy and kinetic energy, if I, again, move my face out of the way, the kinetic energy of solids is going to be very, very low. In a solid, the particles are barely moving. They're just vibrating in place. So we would say that their kinetic energy is very, very low. As they become liquids, as they transition to a liquid, the particles get spread apart more and they start moving a little bit faster. So they have more kinetic energy. Remember, kinetic energy is the energy of motion. And then gases, the particles are whizzing by each other, and if they hit one another, they're going to collide and then bounce totally off. And so they have the highest amount of kinetic energy. So let me sum that down. Solids have the lowest kinetic energy, liquids have a medium amount, and gases have the most. So here are some slides to help you. Kinetic energy is the energy of motion. And when heat energy is absorbed, the molecules move faster and they're going to have more kinetic energy. And when heat energy is released, the molecules move slower and have less kinetic energy. So the type of phase changes. If we transition from a solid to a gas, that's going to be called sublimation. So again, when a solid goes to a gas without going through the liquid phase, it is called sublimation. If we take something that's in the gas phase and change it to the solid phase without going through the liquid phase, that's called deposition. You can think deposition means to deposit something. So you're taking something that's in the air and forming an actual physical solid that you can hold in your hand. The two most common that you probably know is the ice cube example. So if we take an ice cube, which is in the solid phase, and we melt it, it's going to become a liquid. So going from a solid to a liquid is the melting phase. Going from a liquid to a solid is a freezing stage. And all of you have experienced this. If you have ice cube trays sitting in your freezer and let's say they're empty, you fill them with water from your tap, and then you put them back in the freezer, and the next morning you wake up and you have a bunch of ice cubes to make iced coffee or iced tea, or to add to your water if you like ice cubes in your water. From a liquid to a gas, that is evaporation. And then from a gas to a liquid is condensation. Now, evaporation happens on its own. You don't need any heat to cause evaporation to happen. So we generally use the term vaporization. So when a liquid goes to a gas, it's becoming a vapor. It's being pushed out into the air, and we call that vaporization. So again, melting is from a solid to a liquid. Heat energy is going to be absorbed. Molecules speed up. Molecules move further apart. And molecules are going to have more kinetic energy. In freezing, the phase change is from a liquid to a solid. Heat energy is going to be released. Because it's released, molecules are going to slow down and they're going to move closer together. And molecules are going to have less kinetic energy. Vaporization is a phase change from a liquid to a gas, and it occurs at the exact boiling point of matter, and heat energy is absorbed. Therefore, the molecules speed up and the molecules move farther apart. Let me just pause here for a second and just stress to you that if you have heat energy absorbing, the molecules are going to speed up, they move farther apart, therefore they're going to have a greater amount of kinetic energy. So condensation, all of you have experienced that on a glass of water. You leave it out, that had ice in it, and when you come back, your glass sometimes has a little bit of water droplets on the outside of it. So again, condensation is the phase change from a gas to a liquid. Heat energy is released. The molecules are going to slow down. They're going to move closer together. Therefore, they're going to have less kinetic energy. Sublimation is the phase change from a solid to a gas. Again, I want to stress here that you're skipping the liquid phase completely. It's just going straight from a solid to a gas. The most common example of this that I can think of is dry ice. If you buy Jenny's ice cream, one time it was on sale and they were doing like one of their pint sales, and what you notice is all of their pints of ice cream are shipped in dry ice. And if you leave dry ice out on the sidewalk, it's going to go straight from a solid to a gas. Heat energy is absorbed. The molecules are going to speed up. They're going to move farther apart, and the molecules are going to have more kinetic energy. So deposition is the opposite of sublimation, and it's when you go from a gas to a solid without going through the liquid phase at all. And heat energy is released. The molecules are going to slow down. They're going to move closer together, and therefore you're going to have less kinetic energy. The last part of this is we're going to look at the phase change of water diagram. And what you want to look at when you look at a diagram is you want to look at the y-axis. The y-axis is always going to be a vertical. The horizontal axis is the x-axis. So if we look at this, the x-axis is labeled heat energy, meaning over here near the origin or near where the two lines intersect, there's very little kinetic energy or heat energy. But when we come over here towards the gas, there's going to be a ton of heat energy. On the y-axis, down here near where the two lines intersect, there's going to be very little temperature. And near the top, you're going to have your higher temperature. So what you need to know for the phase change of water is that each vertical, or not slanted is a better word, Each slanted line represents one of the phases. So if you hold your hand up, there are 1, 2, 3 slanted lines. Well, in order to have a solid, we know that the temperature has to be low. So A has to be our solid phase, C has to be our liquid phase, and E has to be our gas phase, because over time we're adding more and more temperature, and solids are going to be much colder than gases. On these horizontal lines, if I'm going up the line and I'm going from a solid to a liquid, we're going to melt the substance. If we go from a liquid to a gas, we're going to vaporize the substance. Whereas if we're coming down towards the left and we're starting at a gas and we go down to a liquid, that would be condensation. And if we go from a liquid to a solid, that is freezing. So you are going to want to know on the phase change of water diagram where solids are, where liquids are, and where gases are. So point A, only solids are present here. There's no liquid here. It's completely solid. And this is going to occur below 0 degrees Celsius. The temperature can change during this phase, but it will never be above 0 degrees Celsius. If it was above 0 degrees Celsius, it would have started to melt already. Point B, this is a phase change. It's going to occur at 0 degrees Celsius, and there's going to be no temperature change during a phase change. And the reason for that is because all of that heat needs to be transformed into kinetic energy to help push the particles apart. So water turns from a solid to a liquid when heat energy is absorbed. And water turns from a liquid to a solid when heat energy is released. All right, looking at point C, only liquids are present here. Again, there's no gases, there's no solids here. And it's going to occur between 0 degrees Celsius and 100 degrees Celsius. And temperature can change, but it's always going to fall in that range from 0 to 100. Letter D is a phase change, and it occurs at 100 degrees Celsius, and there is going to be no temperature change. And this is where water turns from a liquid to a gas when heat energy is absorbed. And when water turns from a gas to a liquid, heat energy is going to be released. And then the last phase, or the last point, is point E. And at point E, only gases are present, and the temperature has to be greater than 100 degrees Celsius. And the temperature will always be above 100 degrees Celsius and can vary for water in the gas phase. So that's all I have for you today. Make sure that you follow through with this video and take care. Bye.